Okay, so here I'm going over one of the questions from homework. So this is the screenshot of the problem. You guys have piecewise defined function f of x equal x plus 3 when x is between -2 and 1, 9 if x is equal 1, and negative x plus 2 if x is greater than 1. And first in part A, they ask you to find the domain. So the major question was about how to figure out what is the range of the function, but before I would jump to range, I want to answer all the questions. So part A, they want you to find the domain. So let's find the domain. So what you're going to do with the domain. So when you're looking for the domain, that's your x-axis. So you're looking for that condition. So the first part, the first function is x plus 3 for x's between -2 and 1. So I'm going to graph all of them, all of those conditions. X is, and I will use different colors. So the first one will be in red. X is from -2 to 1, including -2, but not including 1. So this is the first condition, okay? Now, the second condition will be in yellow. We have that function will be f of x equal 9, which is horizontal function. If x is equal 1, that will be just point. So x equal 1 right here, so including that point. And the last condition will be in blue. Domain will be x is greater than 1. So x is greater than 1. That will be everything greater than 1. Okay, so just give me a second. So the domain of this piecewise defined functions, everything what we shaded. So the answer for the domain are from -2 to positive infinity. So everything what we shaded. Or again, here they not really specific how they want you to enter the domain, or if you need to use inequality notation, that will be x is greater or equal -2. Okay, so interval notation is from -2 bracket to positive infinity. So again, we're combining, so that's the domain right here. This is the domain. So we're putting all the pieces together. So this is the domain of piecewise defined function. Okay. Part B, you have to locate any intercepts. So B, let's see. Let's see if we can find any intercept. So let's start with X-intercept. X-intercept, you need to make y equals 0. Okay. So X-intercepts, I need to make y equals 0. So I'm going to start with the first function right here, the first equation. So we have y is equal x plus 3. And again, the domain of the first function is bracket from -2 to 1. So to find the x-intercept of the first function, make y equals 0. So I have 0 is equal x plus 3. Solve for x, you're having x equal -3. Okay, so look what happened here. The first piece of this function, which is x plus 3, doesn't have x-intercepts because look what happened. We end up with x equal -3. And x equal -3 doesn't belong to the domain of the first function. So pay attention to the condition. So the first function only works for x's from -2 to 1. So x equal -3, it's outside of the domain. Of first function. So no x-intercept. So we're going to ignore that. Now, we're still going to work with the first function. Let's figure out if the first function has a y-intercept. So y-intercept means make x equals 0. So here, again, I have to make x equals 0, and I'm checking if x equals 0 belongs to the domain of the first function, which is yes. So that means I can find the y-intercepts for the first function. So y-intercept will be y, it's equal x plus 3, and we replacing x with 0, so we have y equals 0 plus 3, y equal 3 is the y-intercept. So again, when you look for x and y intercepts, make sure that we can find them. Now let's talk about the second function right here. I'm talking about function right here when f of x is equal 9. So that means y is equal 9. So look what happened. Okay, y is equal 9. I just quickly will graph that. If x equal 1. So if you will need to graph the second piece, so you're going to locate x equal 1 on the x-axis, y equal 9 on the y-axis, and technically the second function just gives you a point. Okay, so that's your second function. So look what happened, it's just a point. So we don't have an x-intercept and no y-intercept for the second piece. Okay, and function number 3. So function number 3, when we have y is equal negative x plus 2, and function number 3 works only for x is greater than 1. So let's see if we can find the x-intercept. So we're going to make y equal 0. So we have 0 is equal negative x plus 2. That means x is equal 2. And now when you find that x-intercept, let's check if x is equal to belongs to this domain, which yes, because the last function works for x is greater than 1, so 2 is definitely greater than 1. So we have x-intercept. So this is x equal to is the x-intercept. Now question is, can we find the y-intercept for the third function? So to find the y-intercept for the third function, you have to make x equals 0. However, that doesn't make sense because look what happened. The third function works only for x is greater than 1. So we cannot find the y-intercept for the third function because x equals 0 is outside of the domain for the third function. Okay, so there's no y-intercept for the third function. So here, overall, this piecewise defined function has y-intercept equal 3 and x-intercepts equal 2. Okay, so that was B. Now part C, graph the function. Okay, so here I will graph it by myself and then you guys will just quickly have to select it. Actually, the student who sent me that that question graph the function correctly. So let me maybe explain why graph A is correct. So this is how you graph piecewise defined function. You have y equal x plus 3. And this graph works only for x's from -2 to 1. Okay, so to graph function like this, again, you guys already know that the slope is equal 1, y-intercept is 3, so you have a point 0. Okay, so what I'm going to do to graph the first one, and I will just use maybe red. Okay, so I will locate point 0, 3. I will erase that later, and the slope is 1, which means I will go 1 up, 1 to the right. 1 up, 1 to the right. Or you can do 1 down and 1 to the left. 1 down and 1 to the left. Oh, okay, I'm sorry. I messed up with this one. Look what happened. First of all, we have to figure out the unit 2, 4, 6, 8, and so we're going by 2 here. Okay, so Y-intercept, it's 3, so that 3 will be here. So now it makes sense. That's 3, slope it's 1. So, okay, right here. So this is the graph, technically, if you will extend it. So this is the graph of the first function. However, look what happened. This first function works only for x's from -2 to 1. So you need to locate -2, just right here, and 1. So that graph only will be from here to here. So I will remove the rest of it. So this is the first function. And why you see the segment, closed circle open, because that only works for x's from -2 to 1. Also, because it's a first straight line, you can just find the coordinates when x equal -2, y will be equal -2 plus 3, which is 1. So that's how we got that point -2 comma 1, -2 comma which they didn't really graph it correctly. Okay, they messed up too, because -2 comma 1, it should be somewhere here. They put us in -4 comma 1. They messed up with this graph. Okay, but from all the options which I see, it's this one. And the last point, you will make x equal 1. So y will be equal 1 plus 3, which is 4. So you have point 1 comma 4, but this one is with open circle, does not belong to that graph. So 1 comma 4, it's right here, this one with open circle. So that's the first graph. Okay. The second graph, you have y equal 9. So that was the first graph. This is the second graph, y equal 1. And that one works only when x is equal 1. Y equal 9 works only when x is equal 1. So here we mentioned that the second graph is just the point 1 comma 9. 1 comma 9, which is right here. So that's the point. And the third graph, let's use green, is y equal -x plus the third graph. Y is equal -x plus 2. And this graph works for x is greater than 1. So to graph this one, again, first I will select what will be the point x equal 1, because that's when you will have an open circle. So then y is equal -1 plus 2, which is 1. So you'll have 1 comma 1, which is open circle, because we start the third graph for x is greater than 1, not including 1. So we have a point at 1 comma 1, just right here. That's why you see open circle. And you have -x plus 2. So next point, select x something greater than 1. So I will select x equal 2 and figure out what is the y coordinate. So we'll end up with 0. X equal 2. So we have 2 comma 0. Second point, and it's just a straight line. So this is piecewise defined function. So definitely the first one is correct. Okay. And now we're moving on to the part which students struggle. Based on the graph, find the range. So range is the y-axis. So first you have to figure out what is the graph. To find the range without the graph, it's very difficult. So even if they won't ask you to graph piecewise defined function, I always will graph it on the paper so I can read that range. Okay, without the graph, it's very hard to find the range. So always for questions like that, graph it. Graph it, even if you don't see the graph, graph it on the side and then find the range. Range is y values. Okay, so to find the range, you're using the y value. So look what happened. I see that this function exists for all the y's I will use purple for like all the y's from negative infinity, and also when you check the range, you're going from bottom to top, from negative infinity up to here, okay? Up to here, this point. So for y from negative infinity, and again, we already know what is the coordinate of that point right here. That's our open circle. So y equal 1. Open, because we're not including that y. Then, actually, look what happened. When, for this point, which was negative 2 comma 1, it's part of the graph. So here we actually including, we're starting the graph from y equal 1 up to this point right here. So actually, we're going to have y equal 1 because y equal 1 works for the second graph. Okay, so the domain will be from negative infinity up to this y right here. Up to here, which is 2, 4. Open circle. And then look what happened. We have a huge gap, plus, and here, don't forget that this is y equal 9, so we have 1 extra point, plus 9. Okay, so from negative infinity, a little tricky, to 4, and then we have gap plus 9. Okay. Okay, so type the answer as a union of interval set. So this is how you will have to type the answer for D. And F, I'm sorry, part E, they asking you if function is continuous on a domain. Function is not continuous because first of all, for function to be continuous, you should be able to graph this graph without lifting a pencil, which is impossible. And also you guys see that we have gaps here, okay? So definitely it's not continuous. And that's it. So that was the problem. Definitely a lot of questions here. That range was a little tricky, but again, it's you cannot really figure out the range without graph. So don't forget that you're checking range from bottom to top. And I want to mention why y equal 1 works, even if we had open circle, because we had open circle and then closed circle on the same height. So technically, if you connect them together, we will have continuous over there. So that y, it's equal 1, it's part of the graph, okay, because we had open circle and closed circle, the same thing like we had with the domain when we had open circle and closed circle. And here we have that gap from y equal 4 up to y equal 9. So that's why I stop at 4. We're not including 4. Union and only y equal 9 is the last y value, which is part of the range for this function. Okay, so hopefully that helped.